Hello everyone, welcome back to our channel. Today's video, I want to show how you can make a AC to DC converter without a transformer or another thing, just using this one, MB10S and this MB BM2P054. So let's start nowadays you have to supply many things using DC and then you need to connect directly to AC, and then sometimes you may using transformer starting to be big, and nowadays we need something small. You need the small things. So why I feel like how can I make this one? So and then you need to even the phone charger need to be small, computer charger. The many things need to be small, but when you're using the big transformer or another thing and some other component, it make a bigger a lot. But when you look this circuit diagram, just it's only this resistor, using only this resistor and this AC and this AC, this is a capacitor, diode, just only few components. Like this component is a few, no big deal. So when you make something, it will be small. So and talking 100%, from AC 220 up to 12 voltage. Even you can converting it to another. Even this one, it can be to be the like some computer using 12 voltage already you have. So yeah, this circuit it's become very important. I think it's very needed for in electronic component, many electronic experiment. This circuit is very needed. So just to have to use this one. This one is the AC, and then this one is the AC to this converter. Even this one. So when you use this one is the inductor. I think nothing special on this one. Like when you go to Google, this is the bridge rectifier. So this one is the bridge rectifier. It's compact, the 0.5 AM bridge rectifier, and see the small package, suitable application with the space like small power supply, battery, charger, right driver. You see, it is type of rectifier circuit that used in diode converting AC to DC. The output is 0.5 ampere. So the high surgery current is able to handle high surgery current with the brief free speaker current, make it reliable. So see, this chip is so good. Like, so now why I check, you have to check the component before you use it. Even let me show you this one. Even this one is a PWM type DC to DC converter designed for the application. So there is AC to DC or DC to DC specified significant product with this one. So supporting 650 MOSFET and supporting both isolated and non-isolated design. The key features for this one is this one, the external. So this one is for AC to DC, DC to DC. So it's very important. So just I show you this one because it is only two main component I use on this circuit. And then another thing, I think you see everything. See, this is the header for output. Mm, and I mean this one to AC input, and then I'm naming this output 12 volt DC output. Yep. I think now it's looking clear. Just only this one is input, this is output. So let's go here. You see, I make it and then I design it. You see, mm, like this one is input, of course. I put the resistor as a show. Then like this one. So because it is the power, you have to creating the copper brain. So see, to make the power feeling free, free, just traveling through the in the wire without just in the feed press. So that the second thing you have to using the larger, like here using 13 mil. Even here you see for the output I put this one. So you see the 3D model how it look like, and you see it's so small. Even the big thing is the header because I use this header. Let me show you something. You see, you see this connection, how you can make this one. So even I put this one, I think it look nice, and I have to show you to teach you how you can make the like things as additional, like this one. How you can make this one? Even look this hole and this hole are different. Okay, let me show you how you can do it. So for the hole, just you can go to this hole and then you see when you come to the general shape, there is rectangle and oval. Just when you're changing this one, you can changing height or width, like when putting 170 mil. You see how it look like? Okay, it's nice. That's why it's one I need to show you. And the second thing, like you see this the wire, uh, this cable, this track wave, this track see you can be connecting here direct, but for this one, just to see where the is traveling, but you cannot connecting direct. So how can do it? Sometimes we see someone creating something like here and then say, wow, how this guy do this thing. Even me before I say like, how this guy do this. Yeah. So let me show you like, mm, let's go on this one. Just you have to go to this one, soldering mask. You have to go to the soldering mask and then choose this one. Okay, let me do it here. And then you see when you do it here, just you have to check soldering mask, and then what is you have choose copper. If you're not choosing copper, just copper alloy on top layer and bottom layer on here. Just choose field, and then you're choosing net, right? And then you're choosing the layer. You're putting on the uh, top soldering mask, right? You see when you make like this one, and then when you press another time, You see how it look like. It's nice. So you have to decreasing the size like this one. Make sure. You see, now it look nice. Yep. That's how even you look this one, you see the house look like right now. Already changed. And the second thing, sometimes you have to check. You have the two layer. You need to check how the uh, rear stack up is look like. In general, say like how can I make? How can I check? I know I putting the wire in the second in the top layer and third layer, and then I see the I putting on the top layer, but you see, oh, this one is on the top layer, but you cannot connecting directly. What is the problem? See, you cannot connecting directly, but when this one you can connect, you can soldering something here directly. So that's why I want to show you how you can check the uh, layer setup. So you can go here to the layer staking, layer staking. Sometimes it's closer just to go to the layer staking, like putting here like two. You look nice. So you check everything started to be up. So when you check rear, the first one is the rear, second one is this one, is top rear, the component, top scale screening. Top screening is this one for the white white color in the blue. Third one, you see where you're crossing your connection. You see on the top one, on this one. You see that's why it's on the top soldering mask. Even when you check on the button, you see you have this one, you have this layer. This layer is button soldering mask, and this one is material for the PCB. It's the material we use is FR4. So that's this one. This is the big one. Is FR4. Then between FR4 and this color there is soldering mask. So yeah, it's good. But even when you're making the more than two layer, this one is two layer, four layer. You have to check how your layer is look like. You know, you have to check everything. I think this one is very, very important. And the second, you learn something new on this project. I hope learn something new on this project. So if you have any suggestion, any problem and thing, you can drop in a comment. Thank you. Bye bye.